For today's lesson, we will be discussing on the basic concepts of circular functions focusing on reference angles and coterminal angles. Before we proceed, let us recall the concepts that may come in handy for a better understanding of the new concepts. A Cartesian plane has four quadrants. Quadrant 1 with both positive coordinates, Quadrant 2 with negative x coordinate and positive y coordinate, Quadrant 3 with both negative coordinates, and Quadrant 4 with positive x coordinate and negative y coordinate.
A clockwise angle rotation is a negative angle, while a counterclockwise angle rotation is for positive angles.
An angle is said to be in standard position if the initial side lies on the positive x-axis. Also, don't forget that one complete rotation is equal to 360 degrees. Coterminal angles are angles in standard position that have a common terminal side. A reference angle is a positive acute angle formed by the terminal side of an angle and the x-axis. For our first example, we have angle XYZ in the first quadrant which measures 35 degrees. To find the reference angle, we should look at the acute angle formed by the x-axis and the terminal side. In this case, the angle is 35 degrees. This is determined through the absolute value of the angle itself. So the reference angle of this angle XYZ is also 35 degrees. For the coterminal angle, we could determine the smallest positive coterminal angle by adding 360 degrees to 35 degrees, which is equal to 395 degrees. We could also determine the largest negative coterminal angle of 35 degrees by subtracting 360 degrees, which would yield to negative 325 degrees.
As for the second quadrant, we have angle HAM measuring 470 degrees. The equations for the angle found in the second quadrant will be 180 degrees minus theta in positive, and in negative we have theta minus 180 degrees. To find the reference angle, we first subtract 470 degrees by 360 degrees to reduce it to the basics, which is equivalent to 110 degrees. Then, we apply the reference angle equation for the positive angles, which is 180 degrees minus 110 degrees is equivalent to 70 degrees. Coterminal angles. To get the smallest positive, we reduce 470 by 360, which is equivalent to 110. For the largest negative, we continue to subtract 110 by 360, which is equivalent to negative 250 degrees.
Let us now move on to the third quadrant. In order to determine the reference angles of the third quadrant, we will use the following equations. For positive angles, angle theta minus 180. For negative angles, 180 minus angle theta. In order to get the reference angle of the given angle, we apply the equation used on negative angles. So reference angle equals 180 minus 140 equals 40. The reference angle of the given angle is 40 degrees. Proceeding to coterminal angles, we first add 360 to negative 140 to get the smallest positive coterminal angle. Smallest positive coterminal angle is equal to negative 140 plus 360, which is equal to 220 degrees. Also, we subtract negative 140 by 360 to get the largest negative coterminal angle. So the largest coterminal angle is equal to negative 140 minus 360, which is equal to negative 500 degrees.
Let's now move on to the fourth problem. In the fourth problem, we see that an angle which is measured about 11 pi over 6, that is the radian form of the angle, lies on the fourth quadrant. We need to find the reference angle and of course the coterminal angle. To find the reference angle for the fourth quadrant, we could use 360 degrees or 2 pi minus theta for positive angles. While for the negative angle, we could just have the angle for what it is, which is represented by the sign theta. In getting the reference angle, we use the equation used for finding the reference angle of the positive angles found in the fourth quadrant. The reference angle is therefore 2 pi minus 11 pi over 6 is equivalent to pi over 6. Now for the coterminal angles, we then add 2 pi, which is equivalent to 360 degrees, to the given, which would result to the smallest positive angle, 23 pi over 6. As for the largest negative, we would then subtract 2 pi from the given, which would result to the answer 11 pi over 6.